The universe is expanding. We have known this for a century, but in the last few years, our measurements have started to scream at us. When we look at the oldest light in the universe, the cosmic microwave background, it tells us the expansion rate is 67 kilometers per second. But when we look at modern stars, the supernovae, the clocks of the nearby universe, the number jumps to 73. This is not a small error. This is the Hubble Tension. In the world of physics, this is a crisis. Imagine you are playing a high-end video game. You walk toward a mountain in the distance. The closer you get, the more the textures change. The physics of the mountain start to contradict the physics of the valley you just left. That is what astronomers are seeing. The textures of our reality don't match. In January 2026, researchers began looking at this discrepancy through a new lens, the simulation reset. If the universe is a program reaching its memory limit, the first thing to fail is the consistency of the laws of physics. We aren't looking at a math error, we are looking at lag.
So I found the second law of information dynamics is not only that it seems to permeate everything in the universe, including mathematical entities, but the universe appears to optimize the optimal. It requires the most optimal compression of information to be minimal. So this is absolutely remarkable. So if this is a law that refers to computational processes and information itself, and the universe does this in everything, it seems to be even biological life, perhaps the universe really works as a giant computer.
To understand the reset, we have to look at the work of Dr. Melvin Vopson. He proposed something that sounds like science fiction, but it is being published in serious journals. The Second Law of Infodynamics. In our physical world, there is a law called entropy. It says that everything eventually becomes messy and chaotic. A hot cup of coffee always goes cold. A building eventually turns to dust. But Vopson discovered that in systems of information like computer code or DNA, the opposite happens. Information doesn't get messy, it compresses. It becomes more organized and smaller over time to stay efficient. Vopson's research shows that the universe behaves exactly like a digital file. It is constantly trying to zip itself. In late 2025, his team suggested that symmetry in nature, the way a snowflake is shaped or the way galaxies spiral, is actually the universe's way of saving power. A symmetric object requires less code to render than an asymmetric one. The universe is lazy, it is optimizing. But why would a natural universe care about efficiency? It wouldn't. A natural universe would be messy and random. Only a system with a finite amount of memory would need to compress its data. If Vopson is right, our reality is a compressed file, and every file has a limit to how much it can be squeezed before the data starts to corrupt. That corruption is the beginning of the reset. At the University of British Columbia, UBC, Okanagan, physicists recently tackled a different angle of this mystery. They asked, can we simulate a universe? The answer they found was a mathematical wall. To simulate just a few hundred atoms at the quantum level requires more classical computing power than exists on Earth. To simulate a whole galaxy would require a computer the size of the universe itself. The UBC Okanagan study suggests that if we are in a simulation, the hardware running our world is not just advanced, it's struggling. The complexity of life, AI, and human consciousness is growing at an exponential rate. We are generating more information today than at any point in history. In computing, when a program generates too much data for the RAM to handle, the system does one of two things. It slows down time, which we see as time dilation near heavy objects, or it prepares for a system flush. Scientists are calling this the information catastrophe. If we create too much information, we might literally overheat the fabric of space-time. The reset is the system's cooling mechanism. It's the only way to clear the cache. So how does a reality reset actually happen? Physicists have a terrifying theory called vacuum decay. Imagine that our universe is sitting in a false state, like a ball sitting on a ledge. If that ball gets nudged, it falls to a lower state of energy. If the simulation needs to reset, it doesn't need to delete the stars one by one. It simply triggers a phase transition. A bubble of true vacuum would appear somewhere in space and expand at the speed of light. Inside this bubble, the laws of physics are different. Atoms don't hold together. Gravity doesn't work. It is a total erasure of the previous version of the world. Because it moves at the speed of light, you would never see it coming. 1 second you are living your life, the next, the simulation has moved on to version 2.0. This isn't just theory. In 2026, researchers started looking at cold spots in the deep universe. Some believe these are scars from a previous reset. Places where the old version of reality didn't quite get deleted properly. They are the ghost files of a dead universe. There is one more piece to this puzzle. It is the most famous experiment in physics, the double slit. We know that particles behave differently when they are being watched. If we don't look at a photon, it acts like a wave, a probability. If we do look at it, it collapses into a solid particle. In the gaming world, this is exactly how occlusion culling works. The computer only renders the room your character is standing in. The rest of the world exists only as code, not as graphics. By observing the universe so closely, by building the Large Hadron Collider and the James Webb Telescope, we are forcing the simulation to render more than ever before. We are making the system work too hard. Scientists are now looking for the refresh rate of the universe. Is there a smallest unit of time? The Planck time is 10 to the power of minus 43 seconds. If reality is a digital screen, this is the frame rate. If we find a way to see between those frames, we might see the system itself. But the system doesn't like to be seen. Every time we get close to the source code, something seems to push back. A new mystery appears, a new tension in the data. The evidence is stacking up. The Hubble tension shows the laws of physics are drifting. Vobson's Infodynamics shows the universe is compressing its data. And the UBC math shows that our complexity is reaching a hardware limit. A reset is not a death, it is an update. We are living in a moment where the limits of reality are no longer philosophical questions. They are measurable mathematical facts. The scientists didn't find a god in the machine. They found a restart button. When the reset happens, there will be no warning. There will be no sound. The screen will simply go dark, and a new vista will begin. This is Versa Vista, and for now, we are still online.